Molecules are groups of atoms that are held together by chemical bonds. So just like humans don't often live solitary lives, atoms don't either. Atoms, like humans, live in groups. And what holds these groups of atoms together are bonds. And so a group of atoms is a molecule. But why do atoms form these bonds in the first place? One of the main reasons is to become stable, because atoms that don't have bonds are often unstable. Also, because opposite charges attract. Sometimes you'll have an atom with a negative charge and then another atom with a positive charge. And of course opposites attract, and those two atoms come together and just hang out by each other, and that's a bond too. And sometimes both of these things happen. These processes all occur naturally. So one of the reasons why atoms form bonds is to become stable. And another way of saying this is that atoms form bonds to achieve something called octet. Let me explain that a little bit. Atoms are stable with a full outer shell. We talked about, or you learned about valence shells in the past. A valence shell is the outer shell of an atom where you find the outermost electrons. Since most shells are stable with 8 electrons, and since most atoms prefer to have a full outer shell, we call this rule the octet rule, octet as in 8. An atom can achieve octet by giving away electrons, or by taking more electrons on, or by sharing electrons. And all of these things can result in bond formation. If you look at the picture above, we see an atom of helium and an atom of nitrogen. One of these two atoms is stable alone, and the other one is not. So which of the two is more likely to form bonds? Let's take a look at this. When we look at helium over here, we can see that its first shell is the valence shell, and this shell is full. So this particular atom is stable just like this. If we come over here and look at nitrogen, we can see that there are 5 electrons, 1, 2, 3, 4, 5 electrons in the valence shell. The second shell is the valence shell here, and the second shell becomes full with 8 electrons, and there are not 8 electrons in this valence shell. So nitrogen here is not stable, and it is likely to form bonds to become stable. The first type of chemical bond we're going to look at is the ionic bond. I mentioned that one of the ways that an atom can achieve octet is to take on electrons or give electrons away, and that's what happens with an ionic bond. Now, atoms, sorry about that, atoms can give away or take on electrons, but not too many. Usually an atom can only give away 1 or 2 electrons. Transferring 3 or more electrons is just too hard. So let's take a look at the picture on screen. We have a fluorine atom and a lithium atom. And if you look at fluorine, you can see that it has 7 electrons in its valence shell, and lithium has 1 electron in its valence shell. So what's going to happen here is lithium will donate its extra electron, if you will, to fluorine. And now both of them have full valence shells. Now the first shell becomes the valence shell in lithium, and it's full. And now fluorine has 8 electrons in its valence shell. Now the ionic bond hasn't formed yet. It's about to right now, though. Watch this. So if you notice, the two atoms move closer together, and the reason why they moved closer together was because they had developed charge. They each had developed opposite charge. Fluorine had developed a negative charge, and lithium had developed a positive charge. And the positive charges, or excuse me, the opposite charge is attracted to each other. So what happened here was an electron was transferred from lithium to fluorine. The atoms became charged, in other words, they became ions, and then the opposite charges attracted, forming the ionic bond. Notice they're not touching. This is not a touching relationship. So let's take a look at this in more detail. This is what the fluorine and lithium look like before the electron transfer, right? Fluorine has atomic number 9. It has 9 protons then, and if we assume neutrality, it has 9 electrons, and there's no charge. It's neutral. Again, assuming lithium is neutral, the atomic number is 3, which means it has 3 protons, and so it also has 3 electrons. Now, after the electron transfer, things are a little bit different, right? After the electron transfer, The fluorine now has 10 electrons because it gained an electron, right? So it has a -1 charge. To kind of explain that to you, I'm going to show you this. Right? Here are the protons and the electrons in fluorine before the electron transfer. And notice everything cancels out. But once that electron was transferred to fluorine, we now have an extra negative charge, which is what gives fluorine the extra negative charge. Looking over at lithium, right, after the electron transfer occurred, lithium only had 2 electrons, right? So it had a +1 charge because there were 3 protons, excuse me, and only 2 electrons, right? Before the transfer, the positives and the negatives, the protons and electrons, if you will, they canceled out. But after, right, because we've lost an electron, we've given that to fluorine, we have an extra proton and now a positive charge. So that's how these atoms become charged, and then the opposite charges attract and hang out by each other. So if a neutral atom gives away or gains an electron, it becomes an ion, and then the opposite charges attract to one another and they hang out, and that's really the basis of an ionic bond. You're familiar with table salts. Sodium chloride, or NaCl, is table salt, and what holds the chloride ions close to the sodium ions in the table salt crystal are ionic bonds. So let's take a look at this particular ionic bond. Here is a sodium atom and a chlorine atom. Okay. Sodium has 1 electron in its valence shell, and chlorine has 7 electrons in its valence shell. Okay. So what we can do is we can transfer the electron from sodium to chlorine. Now sodium has 8 electrons in its valence shell, so notice the second shell becomes its valence shell. And chlorine now has 8 electrons in its valence shell, so they're both stable now, they're both happy. Okay? But sodium gained a positive charge because it lost the electron. Chlorine, because it gained an extra electron, electrons have negative charge, now it carries itself a negative charge. And the opposite charges hang out by each other. Do the atoms of the ionic bond touch once the bond is formed? So is sodium actually touching the chloride ion? No, it's not. So this is, like I said, not a touching relationship. So here's a review of the ionic bonds. Ionic bonds form when atoms transfer electrons to achieve octet, in other words, to become stable. The electron transfer creates oppositely charged ions, and then the oppositely charged ions hang out by each other, and that is the ionic bond.